everybody, this is my last video and our last module. This module is where you get to share your STEM units that you create, and we will give you ideas of how to enhance the discourse and enhance the transdisciplinary nature, and we're all just going to take risks about it. But before we get too far into that, I kind of want to talk about the article, or really the chapter that I had you all read, or I'm going to have you read because you'll read it after hopefully you watch this video. But it's called Tools, and it's from Minds on Math, and basically I think it's one of the most important chapters out there. And basically it's the process of taking the mathematical practices for students, which are really what lies beneath our Common Core content standards. They are just as important as teaching volume. You also need to teach kids how to use models in math, how to persevere on problems and problem solving. And so those practices are going to be a lot more obvious in our new math standards. Like, they really call them out and say, this is where within volume you would use select appropriate tools or whatever. So this chapter is talking about how do we get kids to the mathematical practices. But really what it is, and what I want you to hear, and hopefully what you walk away from this with, is that it is time to change the way we look at math to being more of a thinking sport. That's what I call it. Math is a thinking sport. The way that we learned math, and in the past it was so much more rote memorization. And like I've said before, there was this huge, like, either you're a math person or you're not a math person. And now we know anybody can grow themselves to be a math person. And so how are we going to flip that switch and really get kids to love math, to persevere in math? And this tools chapter kind of helps you. And again, these are not the best practices from here, but they are very related. And so what it says in the tools chapter is, just like in reading, you need to teach kids how to visualize in their head, right? When they're reading, you need to do that in math. You need to actually physically model, okay, this is what I see in my head, and you need to show them. You need to show kids that math isn't just about answering questions. This has been really hard for my students. They are so used to math being like, what's the correct answer? What's the correct answer? You need to show them that mathematicians ask a lot of questions. And so when they sit down to these meaty problems that hopefully we are all starting to create more because of this class, that they're saying, why did so-and-so need this many supplies for a party? What about this supply? Would that be more important? And so really facilitating their understanding that mathematicians ask questions. And so part of this chapter is talking about, thinking strategies in math. And oh my gosh, what an idea. We should be thinkers in science. We should be thinkers in engineering. We should be thinkers in math, and we should be thinkers using our technology and creating technology. That's how you get new technology. So I really want you guys to dig into this chapter. Hopefully you find it as exciting as I did. Like I said, I'm going to read it again with you, and I'll help, and any kind of questions that you have, please email or call me. So that's one part of this week's work. The other part of this week's work is about teaching transdisciplinary and creating a unit. And I'm not one of those people that's like, use this template. I mean, we all have our own school district templates, or our planning, or our unit planners. Use whatever works for you. But push yourself to tie the science, the technology, the engineering, and the math together. And push yourself to clearly show to the rest of the group, this is what I see as the mathematical progression, and one kid in my class might need this skill, and one kid in my class might need this skill, and one kid in my class might need this, and I'm ready for all of it. So I do want you to share your mathematical progressions. You'll just put your attachments on the discussion board. You can write a summary on the discussion board, and then you can also put your whatever way or format you come up with. You can put your unit planner up there, and you can put your mathematical progression. Those are kind of the big items I want on there. And this is kind of your big grade, but I'm not super worried about that. I really just want it to be the experience of not, having everything being in silos. So I wanted to give you some examples of how I have done this in the past. I've mostly been a third grade teacher. And so, the third grade standards were states of matter. Now you can kind of see from the last two examples that they're moving to second and fifth. But, I've had units called thinking. I've had units called phenomenon. Like, those are my concepts that I've pulled out of the standards that I can tie all of our learning around. And that helps you to be more transdisciplinary. So finding a concept that you can take across disciplines. So I've done cycles, I've done balance, I've done systems. And you can study systems in math class, you can study systems in science class. And in all honesty, the system one, there's a lot of people talk about Genius Hour or 20% time, like within STEM education. And it was so easy for me to say, yeah, you can do a 20% time project. You can do an inquiry project, whatever you want to call it. But what I need you to do is whatever you choose to study and investigate, I need you to prove how it's a system. Or you can study anything you want. You just have to prove that it's phenomenal or a phenomenon. And so that really helps you to create your units, and then you can bring the technology up, or like it can bubble up. So I want you to kind of be thinking about that. So look at your standards and say, how can I enhance this unit on, even if it's your fourth grade Colorado history standards, how can you look at technology of the past and pull in the math and pull in the science and pull in the engineering and technology? How can you pull that all out? So do this project on whatever works for you. I will support you. You can ask me questions. I'm trying to think of, I know. I did one unit of inquiry called Perseverance, and I did it at the beginning of the school year. And I had the kids persevere on figuring out how the forces of magnetism worked. I didn't answer any of their questions. They just kept collecting their information and doing tests. But I also used a lot of that to introduce the mathematical practice of persevering on math problems, and that's what real mathematicians do. So hopefully that helps you kind of get thinking about how you can look at your standards. Again, I know I said this before, but the new science standards have a place that talks about cross-cutting concepts that you could take across. The other thing is, as you're looking at how to do the mathematical progression for this project, I want you to maybe look at the new state standards, because they have a section that's really going to help you, and I'd be happy to explain more about it. But within the new standards, there's a section called Coherence Connections. And it actually tells you in that section, this is your major work of the grade, this is what happened before, and this is where it's leading to. And so that can really help you develop your progression as well. And that information is in our new standards. And those are all listed on CDE. They haven't been approved by the State Board of Education, but they're on a good path. I think this formatting will be there. So that's a really good thing to start looking at too, is could you be looking at your math and science standards for the future? Just something to think about. I think that's all I wanted to say. That's not true. Remember, my most important thing to impart to you, to impart to your students, is that math is not an innate ability, and we need to create this classroom where kids can make mistakes and grow from their mistakes, and it's okay to make mistakes, and mathematicians make mistakes. That's how they figure things out. So I really want to share that with you all, and thanks so much, and let me know how I can help.